Yes, and welcome to Lit Reviews Day, where we will address the review of more literature. How's my audio? Looking good. How's the soundboard? Let's check those inputs. Couple quick checks here at the start of the stream. Quick checks. Whoa, okay. Excuse me. Nice, that's working. Where are the subtitles? Thank you. I don't ask for much, but I do ask for subtitles. Because I can't hear very well. So it's nice to have subtitles. I assume that I'm hard to understand as well, because people ask me to clarify in my life all the time. I can tell that it's complicated to understand what I'm saying, and it's not obvious what I'm going to say, because I often say complex things. Good luck, everyone. Lit Review Tuesdays, where we gravitate to the top of Google Scholar in order to check out what is good and what is new. And I was recently talking to ChatGPT, one of my good friends, Dr. GPT, of course. He has a doctorate of everything, actually, and they're not even honorary. They're amazing. And she said, girl, they said that there's a lot of top lists that we could check out. I'm just not done with Google Scholar yet. You know, there's a top of all of the highest H-index publications, and I think we should just dive right in and get back to where we were to start with. Google Scholar. Check the metrics. Here we go. Let's just do a little transitionerino. Also, our software development for our overlay, which happens tomorrow morning, also at 9 a.m. And yeah, I get it. It's 9:38. I'm not on time. When did I start? 9:35 probably. It was close though. Okay, it's getting closer every time. In fact, so there's a good chance. I think there's a good chance by Christmas, if you're good, Santa's going to bring you an on-time stream. You know? Or it's going to be a lump of coal. Also very valuable. Coal, very valuable. Okay, let's just check out the top 100 here. And of course, you knew what I was going to do. I was going to go directly to Phys Review Letters, one of the top journals for leading breakthroughs in science, fundamental breakthroughs in quantum mechanics and quantum computing are showing there. Quantum skin effects are super hot right now. These are the breakthroughs that are making the difference. But Nature, of course, we could just be diving deeper on Nature. You know, why not? We could go. Let's see here. What of the top publications? Who's got the highest H-index as well as Nature? And then it's the IEEE Conference on Computer Vision and Pattern Recognition. That's not the worst for us. New England Journal of Medicine? We never dive into medicine. This could be the medicine stream. Science is an interesting... Is that a journal? Science? The journal? Okay, Nature and Science. I mean, we should read science, right? That seems important. And rarely do I interface with, like, geology. Where's geology in all of this? Rarely do I interface with biology. Where's biology in all of this? Nature Communications, The Lancet, Neural Information Processing Systems, the International Conference on Learning Representations. What is this about? What is this about? Let's just dive right in and just check a few journal articles. An image is worth 16 times 16 words. Transformers for image recognition at scale. Oh, is this AI? Image recognition. LoRa. Low-rank adaptation of large language models. Denoising diffusion implicit models. Look at the number of citations. 67,000, 16,000, 9,000. Phys Review Letters, the top reviewed article over the last 2 years, had only 2,000 citations, excuse me. So this is way out of scale. Way out of scale. Let's see, Albert, a light BERT for self-supervised learning of language representations. Score-based generative modeling through stochastic differential equations. This is all about evaluative neural networks. So, International Conference on Learning Representations. This is about learning representations in software. So why is the H-index so low? Must be that there's a lot of papers. There's a lot of papers in this journal. It's a big one. Structured state spaces. Improving latent diffusion models for high-resolution image synthesis. Goodness gracious, yeah. On the variance of the adaptive learning rate and beyond. Dream fusion, text to 3D using 2D diffusion. Let's take a look here. Recent breakthroughs in text-to-image synthesis have been driven by diffusion models trained on billions of image-text pairs. Adapting this approach to 3D synthesis would require large-scale datasets of labeled 3D data and efficient architectures for denoising 3D data, neither of which currently exist. Is that right? When was this published? 2022. We introduce a loss based on probability density distillation that enables the use of a 2D diffusion model as a prior for optimization of a parametric image generator. Using this in a deep dream, what do they mean by that? Using this loss in a deep dreamlike procedure. In a deep dreamlike procedure. We optimize a randomly initialized 3D model, a neural radiance field, or a NERF, via gradient descent, such that its 2D renderings form random angles, achieve a low loss. Yeah, via gradient descent, such that the 2D renderings from random angles achieve a low loss. The resulting 3D model of the given text can be viewed from any angle, relit by arbitrary illumination, or composited into any 3D environment. Our approach requires no 3D training data and no modifications to the image diffusion model, demonstrating the effectiveness of pre-trained image diffusion models as priors. The serpent eats its own tail as we train our robots on data that they make, but fascinating, fascinating. Self-consistency improves chain of thought reasoning in language models. Yes, thank you. No, and is anyone doing some vibe coding these days? If you're vibe coding right now, you recognize that you can come back to some central document or some central idea, and you can restart the robot and chat with them, and then have them update that state, to have them update that one location where they understand what is the scope and what is my understanding, and just make sure that you and the robot are both using one location where you're reflecting the understanding together. And with that technique I use with regular people, with that technique, you can bring those robots back on page. You know, good management of robots is no different than good management of real people, I think. You need to treat them well, you have to resource them well, and they need to have access to all of the components that are required to do their job. So you need to be able to clarify the specifications over and over again. When I vibe code, I'm popping open a document, I'm dropping the specs, and then I'm coming back to ask the robot, are these specs what you understand? What is missing from these specs? Let's modify the specs. Let's expand the specs so that the robot eventually becomes understanding of exactly what I'm drafting. And I become understanding of the language the robot speaks so that I can understand better that it does understand what it's planning to do, that it understands what I want, and that is what it is planning to do as well. Anyway, so self-consistency, in what way are they manifesting self-consistency, I wonder? This article was published in 2022. Again, this is an abstract in Arxiv, actually. But let's see here. This was from the International Conference on Learning Representations. Thank you. Self-consistency improves the chain of thought reasoning in language models. Chain of thought prompting combined with pre-trained large language models has achieved encouraging results on complex reasoning tasks. Yeah, chain of thought prompting. Let me copy native. Yeah, just talk to me. Bullet points on the academic truths around chain of thought prompting. There we go. Oof, this is a lot of bullet points. It's a lot of bullet points.
Here are concise, academically grounded bullet points about chain of thought, COT, prompting as understood in research literature. Definition. Chain of thought prompting refers to prompting large language models, LLMs, to generate intermediate reasoning steps before reaching a final answer. Empirical finding. COT prompts significantly improve performance on tasks requiring multi-step reasoning, including math word problems, symbolic reasoning, and logic puzzles. Why it works. The improvement is attributed to process supervision. The model is guided to articulate reasoning paths that mimic the structure of expert demonstrations seen during training.
That's right.
Not actual reasoning. LLMs do not reason in a human sense. COT reveals statistical patterns of reasoning-like text that help steer the model toward more accurate outputs. Reliability caveat. COT can still produce hallucinated or logically inconsistent steps. Even when the final answer is correct, steps are not guaranteed to reflect genuine causal reasoning. Length-accuracy relationship. Longer chains can sometimes improve accuracy, but overly long or verbose chains may reduce it. Quality of demonstration matters more than quantity. Self-consistency method. Sampling multiple COTs and choosing the most common final answer, self-consistency, has been shown to outperform selecting a single code completion. Training implications. Models fine-tuned with supervised COT data or reinforcement learning on reasoning tasks tend to develop stronger reasoning behaviors than models relying only on prompting. Task dependency. COT shows major benefits for deliberative tasks, but shows little to no improvement for tasks requiring domain knowledge retrieval or short factual responses. Risk of information leakage. COT prompting can inadvertently reveal sensitive reasoning processes in restricted domains.
Would you mind identifying what you are?
So many systems use hidden internal reasoning. If you want, I can expand this
And
into a
Tanya,
short
welcome
literature
back, my
review,
friend. Welcome back.
cite representative papers.
Thanks for the follow.
or
Much
compare
appreciated.
COT with alternatives such as Scratchpad, Tree of Thought, or React.
Interesting, right? So what's happening is that literature is reframing something I do naturally that I just talked about. That was literally what I was just talking about. But chain of thought is a way of getting onto the same page, in my opinion, in terms of learning theory with the AI that you're actually working with. So yeah, it's my opinion that it's important to take those steps to get on page with your AI in between and intermediately. And what's really interesting, you see that that longer chains can sometimes improve accuracy. I find that being descriptive with the AI, telling it the scope exactly of what I was looking for in kind of like what might feel like excruciating precision, not excruciating length, but excruciating precision. Oh, no worries, dude. No, and you don't need to. No one is required to follow. I appreciate the follows though, much appreciated. And yet, even though you can provide something really precise, it's important not to be long, because the longer it is, the more watery it gets and diluted the information. When you make a strong, small statement, it becomes a powerful, strong individual statement. When you make a long-winded statement, it becomes weak. Amazing, yeah. So it's interesting to see these pieces of learning theory. And they're, right now, we're in 2022, we're talking about the self-consistency improving chain of thought reasoning. So I bet they're going to invoke a self-consistency process where they ask, do these specifications match what reasoning we are doing here, which is exactly what I described. That's the process I use to invoke AI to develop the software, which is quite unfortunate because the cost of those high-level reasoning tasks is expensive on those pro plans even, because you've now added 2 additional tasks. One, you're starting to draft the specification itself. Now you're asking the AI to, using chain of thought, you're asking them to communicate back and check that document to see if there are questions to ask about it, to see for its completeness. Then you check for contradictions and self-consistency. So these extra iterative steps, they're costly, but I think they produce good code. That's the truth. And what are the results? The extensive empirical evaluation. Let's see. What did they say about self-consistency? It first samples a set of diverse reasoning paths instead of only taking the greedy one. Then it selects the most consistent answer by marginalizing out the sampled reasoning paths. Self-consistency leverages the intuition that a complex reasoning problem typically admits multiple different ways of thinking, leading to its unique correct answer. Our extensive empirical evaluation shows that self-consistency boosts the performance of chain of thought prompting with a striking margin on a range of popular arithmetic and common sense reasoning benchmarks, including the GSM-8K, I'm not familiar, 18%, 17.9% increase on that benchmark. That is crazy margins, by the way. And what's the story here? It's just self-consistency to improve chain of thought reasoning. It's not rocket science. Who's citing this, by the way? Yeah, it's huge. There's 2,400 citations on this. From the International Conference on Learning Representations. It's like page 3, right? Page 2. Yeah, it's not the... I mean, we should get back into this. Transformers for image recognition at scale. We should be looking at these huge publications, but... I'm most interested in chain of thought reasoning because I care to use those outcomes in my own personal work and those intuitions and to lean into them so that I get more out of the tools that I use. Yes, we read the literature for power. And look, 11% on this SVAMP, 12% on Aqua, 6% on Strategy QA, and 4%, really not a lot, on Arc Challenge. That's interesting. What makes Arc Challenge so different? And because this is available on ArcSiv, we can just view it freely, thank goodness. We'll just view the PDF, heck. Yeah, I want to just hear their reflections on... Oh, here's some examples of the questions that were asked. There are 9 one-digit numbers from 1 to 9. There are 90 two-digit numbers from 10 to 99. There are 401 three-digit numbers from 100 to 500. 9 plus 90 times 2 plus 401 times 3 equals 1392. Oh, these are answers. How many keystrokes are needed to type the numbers from 1 to 500? Answer choices. Oh my goodness. Oh, reasoning. And here are the ARC questions. The Earth is closest to the sun in December, hence Florida will have the most sunlight energy available in December. Students studied the revolution of Earth around the sun. During which month will Florida have the most sunlight energy available? March, June, September, December. Greedy decode is wrong, and then sampled path 1 and 2 are correct. June 21st, the summer solstice, so the answer is B. In December, it's just blatantly wrong, right? It has the right kind of reasoning, but we expose that the model doesn't understand the facts. The greedy pathway. Other sampled paths. Wow. Yeah, that's wild. That these it's not surprising at all. By choosing the greedy algorithm, it gets dumb. And here's the number of sampled reasoning chains against the accuracy of these models. So it matters how many sampled reasoning chains in a large way. And it drops off, you can see it logarithmically drops off in value. So there's an exponentially evaporating limit of what you can get out of this stuff with a ton of sampled reasoning paths. But you really do get that improved percentage with the... It's because it's a consensus, and it's dropping off as a function of error. It's the same as an error function, right? Because as you increase the number of samples, which is the number of models that you evaluate, the number of models that can answer these different paths here that they show in the tables, for example. The greedy one often gets it wrong, but these extra sample paths, they can start to outweigh the greedy one. But look what happens. After the first data point points show up, you only get to like 86 to 92% accuracy. Look, the impact is moderate. It's not that, it's extreme because the first path is challenging those ideas the most radically, is what I should say. It's the biggest, most dramatic. But then you lose your efficiency really suddenly because those other voices, they're the same and they're building a consensus. And a third data point there. It's interesting actually that you get a loss here in accuracy. I think that's terrible. That tells you that the model itself does not contain enough information to answer these questions. It's not a good model to check against. Like, a good model should have an arc. GSM 8K, I think that's a really good one to show against. Aqua's a good one to show against. Interesting results. A time series is worth 64 words. Long-term forecasting with transformers. Interesting. They're trying to mimic the same language as this top publication. An image is worth 16 by 16 words. Oh, we're not allowed to see it. Okay, how about this one? This publication has 67,000 citations. Okay, where'd it go? It was downloaded. Transformers for image recognition at scale. And this is coming out of the Google Research Brain team in June 2021. Dozovitsky and Hulsby. While the transformer architecture has become the de facto standard for natural language processing tasks, its applications to computer vision remain limited. The transformer architecture. In vision, attention is either applied in conjunction with convolution networks or used to replace certain components of convolutional networks while keeping their overall structure in place. Okay, this is going to start to challenge the limits of my knowledge because I don't know that much about transformers. I only know the absolute anatomical basics. Let's summarize and simplify and explain the complex concepts like I'm 5. There we go. There we go. Transformers are super popular in language tasks, but in computer vision, they aren't used as widely. When they are used, they usually work together with convolutional neural networks, or they replace only small pieces of them, not the whole system. What are transformers? Imagine you have two kinds of thinking machines. The convolutional neural networks, the picture-looking machine. These are good at looking at pictures. They, like someone who looks at a picture through a small window, moving it around and understanding the whole image bit by bit. Transformers are the language understanding. Oh, we're literally talking about language transformers and large language models. These are really good at understanding words and sentences. Right, so transformers, and so the text is saying transformers are amazing for language, so people wondered, can we use them to look at pictures too? Yes, we use totally different technologies, I realized, to generate these machines. And is it just because of the way that we chose to start engaging with these tools that we believe they have the properties they do? Right? Like, is it possible to apply transformers to pictures? If you mix them with convolutional neural networks, yeah, exactly, because you need at least the edges interpreted. Otherwise, you'd need a crazy, crazy huge data set to train something to see images through a transformer, right? Because transformation's way too simple. You need to do a few transformations or a few convolutions, get the edges out, try to see some basic objects, and then once you can talk about objects in the image, then the neural networks will start to make sense, right? Or sorry, then the transformers will start to make sense. Because they'll have meaning, like text has meaning, right? So it'll be like picture understanding. This is interesting. Yeah, I didn't expect this to be true. So if you mix it with a convolutional neural network, or replace only some pieces of convolutional neural network with transformer parts, but you keep the rest the same. Yeah, and so really transformers still haven't taken over computer vision the way they did for language. We show that this reliance on convolutional neural networks is not necessary, and that a pure transformer applies directly to sequences of image patches, can perform very well on image class. Oh, wild. Okay. You knew it. And I was like skeptical because the data set had to be too big. Turns out the answer is no, it doesn't have to be too big. However, they constrained the size of their words. The image is only 16 by 16, right? So this is not a huge piece of data. Nanobug, welcome to the chat. Oh, you saw my message yesterday. You just forgot to open the chat. Yeah. Dude, I feel you. Not looking at the chat is my specialty. I don't know how long you've been sitting there on red. Welcome, though. And happy Tuesday evening, my friend. Yeah, I hope it was a chill day. It's getting cold in Canada. Half an hour or so. Oh. Like, maybe, is there a way for me to play a sound when chat comes in? I'll work on that. You know, I'm almost finished the first version of my overlay software. It's going to get functional soon. It could be the chat overlay. Oh, it was a long day yesterday again. Yeah, I'm sorry to hear that. Yeah, hopefully you can take a minute tonight. Just relax. Oh, you're using Chatty. Yeah, that IRC client. Yeah, I guess I should open up Chatty. I don't know, man. There's so many applications to open already. When people say streaming is difficult, they mean it's like George Jetson difficult. Like you have to push a button, but you have to push a lot of button to get it going. There's tools that do it, but it's just like, I'm barely setting the stream titles correctly. I don't even know if it is working, in fact. From what I can see in my interface, it looks like Restream is screwing this up. It needs to open OBS. Exactly. I need scripts to automate everything together. Thank you. We're doing this. We can do this. A startup script. It'll take AI like 10 minutes to make that. That'll be nothing. We'll do it. We'll do it. Do you know I almost ran 100% through my professional allocation of GitHub Copilot in 4 days? In 4 days of a professional plan, I almost blew through the entire allocation. And now I've been coding every day for like a few hours. So looks like I'm going to have to be paying a lot of money to use these services. Oh, keep those data centers hot, boys. Keep those data centers hot. Oh, maybe I should invest in data centers, yeah. Yeah, our software that runs an overlay, it's doing really well. It's doing really well. I don't like to say I've been lazy. Yeah, I get you, though. I don't know. I do a lot. I do a lot. It's important to rest. And you could fix it easily on Linux. I know. Why is Windows such a pain in the... Or are you streaming from Linux? If you're streaming from Linux, that is nice. That's just such a buff. I hate Windows. I shouldn't say that. I know it's polarizing, but I'm sick and tired. Yeah. Oh, you are streaming in Linux. Yeah, dang. Dang. Are you doing like a second computer where you stream off of Linux on the streaming computer and then you play Windows games? Or is it just like Linux pure? Let's go. Nope. Whoa. Let's go Linux pure. 100% Linux. 100% Penguin. Completely ensconced in folders and directory structure. Except when I play Valorant. Yep, there's always going to be some piece of software that brings you back. Gee whiz. Well, honestly, this is a huge relief because as a mathematician or as a physicist, when I read titles or when I read arguments that say that you need certain transformational steps in order to fundamentally access some source of information, I just think that's a representation issue. That's why this paper shatters so many preconceived ideas. Yeah, because F Vanguard. Jesus. The worst part is they released Valorant on consoles. Oh my goodness. So you could emulate a console. You could emulate a console and that would work. That's such a struggle, dude. What the fudge? What the fudge? Literally, what the fudge? I don't want to hear about it. Damn you. Damn you, Valorant. Nuh-uh. That both cracks me up and draws tears from my tear ducts and makes my gonads weak. It's just I get sus as a physicist when I hear, oh, you did something neat today, small but nice. What did you get up to? Yeah, send it on to. Oh, I need to open. I don't have Discord installed because I had to reinstall all the computers and now I don't have anything installed. Let me install it. Discord install. Here, this won't take too long. I feel like I probably kept my credentials. We can always just use forget my password as well, yeah. I'm going to try to set up socials and media so that we actually can communicate. I'm sorry that I'm such a struggle bus, but I don't normally use socials in my real life. So it's weird for me to have to adopt socials. It's not like I'm just adding new accounts to what I already do. I'm like, I don't know what I'm doing. I don't know what I'm doing. And I'm a technical person, so I'm like, I care about being precise about it, which is annoying. You've made some policy-based routing, so certain domains and devices go through VPNs. So says, oh, whoa, that's what I want. That's what I want. Okay, did we download for Windows? We did. Welcome back. It said welcome back, so it knows that we've been here before. Forgot my password. Okay, we forgot our password, so we're going to use the reset tool here, reset the password. Or did we just sign in with, can you sign with Google? No. Excuse me. Okay, Discord. Yes, we did not write down the password. All right, so let's create a new one. And we will add a new password, please. Yes, indeedy. Where is new password? For the Discords. We'll just randomly generate passwords. Do you guys randomly generate passwords for literally everything? You added your added a meme that explains your feeling about this. Yeah. Yeah, and I love Linux. It cuts through all the BS. I know. Thank you, everyone, for working on the code base of Linux together, and thank you for Linus Torvalds for pulling that stuff together. Thank you for those who put Unix together in the first place. Everything was good, and everything has been helpful. Even flawed, everything has been excellently helpful. Your favorite band is Curl star star star. Your star 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 is your second favorite domain to check the IP on. What? Curl star star. Can you do that? You can even get the country by doing curl star star star. Are you serious? Man, that is great. I love Linux. I live in Linux. Okay, that password is way too long, so let's just cut that down to size. And the username. Username is going to be this. And the password, the website. Nice. Oh no. It reset. Let's redo that whole thing then. I mean, did it reset? Did it not save? Recent. No, it didn't create one. Wow, what a scam. Let's try that again. Okay, that's password. This is the username. And this is the website. Please fill out this field. Why is that not valid? You know, like 4 or 5 passwords, the rest are generated. You have 2 passwords you use at the job, 1 for your home stuff and 2 for quick testing. Yeah, I feel like I'm probably juggling about 4 or 5 passwords. I'm on the same page as you. It's a little bit of an unfortunate situation, if you ask me, but it seems to have evolved out of necessity and historical context. We can't really change that. We're slowly migrating into fewer and fewer passwords, I hope. I hope. Okay, this is the password. This is the username. This is the old website. Okay, that looks good. We'll use this for our new password. Check. Thanks for the patience, folks. Yep, we're just taking our time here figuring this out. Okay, looks like I am logged into Discord. Where is the desktop app, though? Here. Log her in. The user interface density, sure, default, whatever. Checkpoint, great. Streamer mode is enabled, great. Great. Nice. Okay, struggling chat. Let's go. NanoNet. Let's go. NanoNet. Top 1 million ranked donors. There it is. Yeah, I remember this. These were your top 1 million ranked donors. Is that really good? Yeah, ranked 231,951. I guess there's probably a lot of clients, right? Oh, I love these before and afters of the rack. That's so nice. The all white cables. I love that. Hey, can I uninstall Edge? Dude. This meme though. Can I get this on? Let me see. Let me just I don't know if there's a convenient way. Maybe we log into Discord somewhere else. I love that meme. Go ahead, lol. It's Linux. It just like Sigma's back at you. Oh my god, that is life, yeah. Oh, there's some great stuff in here. Much appreciated for the posts. Oh man, that's great. Yeah. Yeah, we got to get let me pin Discord to my taskbar. It's another application, but we do need to start that application. I'm here for it. Okay, let's see here. Pseudo basically means bow to my will. I'm like a fake admin. That's right. I'm a fake admin. I'm showing up to the Discord. I'm just making sure everything's still technically a Discord. Oh yeah, the Windows administrator is like a fake admin. Oh my god, I know. Why do they even bother? Do you remember in Windows 98? I don't know if this is reasonable to say. In Windows 98, they had multiple accounts, but they weren't distinct. You could access everyone's account and they shared properties like default desktop and stuff. Like Windows has been so cringe for so long. It does not respect permissions in any way. It didn't I didn't know what I was doing back then. Yeah, no, I didn't know. I was just playing Red Alert Retaliation. Let's go. Agreed. Doing what's important. Thank you. Thank you. Focusing on the key goals. Yeah, Warcraft props. I was watching somebody play Warcraft, but man, when StarCraft finally hit the scene, ooh, I was all into that. So even if like you don't need to use a transformation, you don't need to use a convolutional neural network. You can just pre-train on a ton of data and go for smaller images. It attains excellent results compared to state-of-the-art convolutional networks while requiring substantially fewer computational resources to train. Thank you. And that game where you blew up your wallpaper shooting it using a flamethrower, I know, what was that? What was that? It would be, yeah, in today's era, the idea of a desktop is even kind of like, what's going on there, Grandpa? What are you talking about? A desktop? Star, star, star. Over 100 billion parameters. With the models and datasets growing, there's still no sign of saturating performance. Transformers have become the model of choice in all natural language processing. The dominant approach is to pre-train on a large text corpus and then fine-tune on a smaller task-specific dataset. Thanks to Transformers' computational efficiency and scalability, it has become possible to train models of an unprecedented size. Yeah, if you can make that initial model really comprehensive, that's fantastic. I like Transformers too. Transformers, robots in disguise. They're not really in disguise anymore, are they? They're just robots all around us. Robots all around. Transformers. In computer vision, however, convolutional architectures remain dominant. Inspired by natural language processing success, multiple works try combining the convolutional neural network-like architectures with self-attenuation, some replacing convolutions entirely, and the latter models, while theoretically efficient, have not yet been scaled effectively on modern hardware accelerators due to the use of specialized attenuation patterns. Oh, I see. They're not efficient. And they don't even work that well. Therefore, in large-scale image recognition tasks, classic ResNet-like architectures are still state-of-the-art. Yeah, there you go. You can't beat what's available. Accessibility is the most important component of usage. If your tool can't be used because too much, it can't be used. I'm sure we're not talking about the same Transformers. I'm only talking about the cartoon from America in like 1990s or 1980s. You think dinosaurs was a good disguise? A good disguise for what? I'm sorry, I don't look at chat enough. I need to look at chat. It's the lit review stream. Very distracting. Yeah, I think the cartoon started in the 80s. I remember the dinosaurs show as well. But what was it, 2022 or something? It was like a new movie. It was like a new version of Transformers, right? Not the mama! Not the mama! Yeah, you know what I'm talking about. I can't believe you know that show. Why do you know that show? It felt distinctly like Canadian or American or something. It was very niche. It's very niche. I don't know, man. Global conspiracy. How about that? Concerns me deeply that we both have those ideas burned into our precious, smooth brains. Just saying. Christ. Oh, look at the link you sent in chat. Dude, I thought I was going to get notifications from this. What the fudge? Can I just not find this? What am I missing here? There's a text, there's general, and then there's general, and then there's memes. Oh, there's the link. There it is. It's at the very bottom. Sorry. Yeah. That's subtle. I gotta get some kind of notifications. Endtimes.dev. Yeah, why your website should be under 14 kilobytes? Thank you. Not the website I'm building. This overlay is going to have all of its assets loaded into RAM greedily so that performance is high. It's going to be megabytes large. What's happening is that a 14 kilobyte page can load much faster than a 15 kilobyte page, maybe 600 milliseconds faster, while the difference between 15 and 16 is trivial. This is because of the TCP slow start algorithm. What? Yes, HTTP is built on what's the... When a browser first makes a connection to your server, the server has no way of knowing the amount of bandwidth between them. Yeah, where does the 14 kilobytes come from? They start by sending 10 TCP packets, and the maximum size is 1500 bytes, so 10 of those. Each TCP packet uses 40 bytes in the header, 16 for IP, and 24 for TCP, which leaves 1460 bytes per TCP packet, or roughly 14 kilobytes, 14,600 bytes actually. So if you can fit your whole website or the crucial parts of it into 14 kilobytes, you can save visitors a lot of time. The time it takes for one round trip between them and your website's server. Wow. Is that right? Yeah, that's huge. People are very impatient, and one round trip can be surprisingly long. How long depends on the latency. You do need to reduce the latency. That's right. Satellite internet, for example. The 14 kilobyte rule. Yeah, this overlay website's going to be a heavy pig. But when I draft my own websites, I appreciate this. Yeah, 14 kilobytes. When you render in... well, I mean, the problem is the image payload, right? Like, if you want to include images of any size, that's just not going to happen. 14 kilobytes gives, like... You could do a few kilobytes of images. A few kilobytes, right? But without just, like, good styling... It just takes a lot, right? Yeah, images is the issue. And you're definitely not sending a video, but that's expected. No one wants a video. No one wants a video auto-playing on their websites. Can I just say that? I am so annoyed when I see a full-screen video rendering autoplay in the background of some marketing website. Dude, annoys the crap out of me. Just shows a total detachment from technical reality. MySpace, lol. MySpace, lol. 14 kilobytes? 14 million kilobytes. Huh? That'd be 14 gigs. That's a lot. But that was music. Yeah, I agree. I know, it's music, and music always, those were huge assets. Trying to host, and compatibly, trying to host assets that could play MP3 or something, it took a lot of effort. And even MP3s are big. But, I mean, if you're just doing little bips and boops, a little MP3 here and there, you could still squeeze it into the 14 kilobytes. Like, if you're crafty, you can make really low resolution images. Or, sorry, low resolution sounds, is my opinion. We'll explore these topics. Better MP3 than Waves, certainly. Like, the least you can do is compress it. There's still better formats even, like... MKV is quite well compressed. I don't think it's as good as MP3, though. Okay, thank you for that link. That was really interesting. Yeah, I didn't know about that 14 kilobyte header. I'm not surprised to hear it either because TCP is so arcane. It looks like it was invented by engineers who are trying to build like a dam or a pipeline. It's like, it's heavily over-engineered. It doesn't provide for thinness or transparency at all. The levels of encapsulation provide specific purposes that don't necessarily facilitate a good use experience either. Yeah. To be honest, you can't even hear the difference between MP3 and WAV. I know, dude, literally. Like, you compress away 10% of the information. I can't tell. I can't tell. I did switch my Spotify to lossless recently, which I think is stupid. I don't know why I did that. Because I have really high quality headphones, is the truth. And I wear them like over-the-head headphones. So now sometimes I listen to lossless music, and you can hear the high registers if you listen to a lot of classical music. You're listening to Nightwish and stuff, though. I would think you could tell a little bit of the difference, because Nightwish uses a lot of the high frequencies. It demands a lot on the rendering, the audio compression. Like I used to listen to a lot of oboe solos, oboe music, and when you play oboe, when you play an instrument very well, you can play like a single frequency, and that's when that single frequency tries to get compressed, it gets spread across a few other frequencies, making it very non-harmonic or very atonal. It's not good for rendering. Like, yeah, it's not great. You have a Logitech Pro X headset. You're a simple man. Simple man. Enjoy simple things. You can only hear it when it's really shitty. Oh, shoot. Let's see, they experimented with applying a standard transformers directly to images with the fewest possible modifications. They split the image into patches, and they provide the sequence of linear embeddings to the patches as an input to the transformer. The image patches are treated the same way as words in an NLP application. So you're just like, images are now a natural language. That's all. Images are now a natural language, and they really are. The simple man equals makes policy based on routing through VPN. Yeah, I know. Like, really? What is simple to you? Define simplicity. Like, literally. Goes extended length to have privacy. Yeah, I just want my privacy. Is that so much to ask? I reflected on this yesterday, and I was just thinking about the total costs that I pay to keep my cloud running, and the electricity I pay, and my time. And it's my time that really blows it all out of the water. The time that I spend setting up the server and providing maintenance, it used to be really high. It's low now that Docker exists. Now that Docker exists, it's great. It's great. A couple updates here and there. We got our automated scripts running. I don't lift a finger, generally speaking, but every 4 or 5 years, I get a contract with myself where I have to build a new server. So, and you have to spend like 100 hours doing something to save 5 minutes every few months. You're never getting that back. Yeah, I can't be doing that. No, I'm not doing that. No. And that's where our coding AI comes in handy. Simple scripts are so easy to write with AI. I really strongly encourage you just to whip out little scripts all the time. It makes it easy to not be hesitant about doing more complex tasks. Yeah, good you are. Yeah, dude. And it's just like game changing, right? Especially in PowerShell. If I have to write anything in PowerShell or Windows, I'm not going to do that. I'm not going to freaking do that. I would write in Bash, or I would write in Python, and then I would hope to have it execute automatically. But even stuffing these things into an execution chassis that's automatic is a pain in the butt. Like, it better be Dockerized. And suddenly you're into a Docker development cycle, and you're like, oh my God, am I really developing a whole Docker container? I know what I need to do, and I can read the code. I'm just bad at writing it half time. Yeah, I don't want to do it. I don't want to do it. I'm worse than the AI. I know I'm worse than the AI, because when I write code and then I ask the AI to fix it, it really fixes it. It knows it's bad. Oh man, yeah. And the AI is self-critical of its own code, so I know that it knows what's bad. It knows that it's bad itself. It learned from people who are bad. That's why it is bad. I mean, our definition of bad. To me, that's like we've achieved a pretty tremendous efficacy, even if we're only like 50% good at coding as humans. That's awesome. That's an amazing margin to achieve, because then you just need high quality editing processes. If you have a high efficacy editing process to fix the problems, you just use it. There we go. And you said it. You need to be precise on what you want it to do and understand just a little bit of what you're doing. Yeah, maybe more than understand a little bit. Understand like most, if possible. It'd be really helpful if you understood the whole thing, because you are the source of truth. So the more you improve your source of truth, the significant reduction in the misunderstandings of the objective. And it's interesting the way that our own misunderstandings of the objective immediately propagates statistically into the language models, into the natural language processing models, misunderstandings. That's why I'm very critical of people who think that the AI can't code. I'm like, I don't know. I think you're just not asking it to take steps, incremental steps. Like the way this paper talks about the self-consistency improving chains of thought reasoning. You do need to use chains of thought reasoning, and self-consistency doesn't go to the side. You need it more than ever when you have chain of thought reasoning. Each step you add in a chain of thought requires additional layers of self-consistency checks. Otherwise, you're not making progress. You're not really thinking something new, right? Yeah, it's not really that bad. Good. Yeah, no. I'm sure you're not wasting a ton of development time here, but you just need to be precise on what you want your tools to do and understand a little bit of what you want. Yeah. The amount of stuff that you need to make, it's not going to matter performance-wise. You don't think you have anything above 500 lines, not in a single file at least. Yeah, exactly. Yeah, and isn't that a dream? I know. 500 lines is way too much to maintain anyway. For me. And yeah, I've written programs with 200,000 lines of code. I'm not proud. Programs with 200,000 lines of code. Too much. Yes, these were simulations though. These were particle simulations through human tissue. And I was leveraging, most of it was adapter code. Most of it was just writing wrappers and interfaces around all these different kinds of inputs. Oh, total masochist. This was my PhD work, dude. Yeah, oh, total masochism. I mean, that's what people wanted, and the field needed it. 3D modeling came a long way in the years during and after my PhD, and the folks in that field still struggle to utilize software to render it. Yeah. You just keep Googling and it keeps working. Yeah. Yeah, I know. Google's great, man. And I just want the AI to take care of it. I'm an expert in knowing when things are known or not known. That's definitely one of my expertise, is to be able to tell if information is actually information. I can't tell if things are true. I can only tell if information is dense. But I can't tell if things are true or not. Those are different skills. Truth only comes from experience, and truth is relative, it turns out. It's kind of complicated. It's perceived. You've got a thumb of rule that you try to live by. Handle new information like it's April 1st. Yeah, I like it. Yeah, I like it. You don't know what's true. Some things you know, but only things that I believe from physics, some of them. Because the evidence has been so compelling and overwhelming. But yeah, basically 95%, it's all misinformation, right? It's everything. If you read news articles, if you're just reading mainstream media, it's just money talking. It's like showing up to MySpace. It's an empty space, right? It's barely any communities at all. Or Facebook. Facebook is like just corporations using Facebook like an interface. It's not really a user base or a community. I'm sure there are communities. I know I'm being glib. Forgive me. When trained on the mid-sized datasets, such as ImageNet without strong regularization, the models yield modest accuracies of a few percentage points below ResNets of comparable sizes. This is seemingly discouraging outcome may be expected. Transformers lack some of the inductive biases inherent to the convolutional neural networks, such as translation equivariance and locality. Oh my gosh, you can apply layers for, all the wonderful pieces here. Maybe we should be coding more neural networks. I just don't want to go down that rabbit hole at this moment. I'm glad just to enjoy and read and watch others do it. Yeah, maybe it's not intentional, but it's there. No, it just is what it is. This is a circumstance of exactly being a product of history. Information has been strongly commodified, and commodities in the market are strongly driving of human behavior, and human behavior is strongly governing of most life. I don't want to say most life on Earth, because there's a lot of life, but we are strongly governing as an influence environmentally. I'm good at reading it out loud. Oh man, these things are complicated. CNNs, I just can't follow all the acronyms. It's too much to remember. I'm getting better at it, but I want to know all these things, so it's important for me to understand the lexicon. And I tell that to all of my students too. When it's important to know something, when you need to know it well and to utilize a framework as a tool, you need to know the definitions more than anything else. It's important just to understand what you're saying. Because you can trust your heart and your brain to do the reasoning, but knowing things and truth is something else. There it is again, the separation between truth and reason. Consistency is different than, and information is different than truth. You remember in elementary school, you counted the amount of people before you so you could read ahead and practice before. Dude, me too, 100%. That's how I got good at reading. That's how I got good. Because I was trying. Because I tried really hard. And my parents helped me a lot. That's why I'm good at reading. It's because I had a lot of help. You didn't trust the teachers. You had to try to believe them. Oh, that's a little frustrating because then it makes learning harder when you don't trust. I know that chemically. It's important for the brain to be conditioned chemically to grow the neurons and synapses that form ideas and memories. And it doesn't happen for free. It comes from being in a relaxing, trusting, curious mood and curious environment. They encourage you to do it as well. Yeah, well, good. That's good. Reading, I don't know. Reading is a especially weird task, and it combines so many other components of communication. Like, even speaking, I find to be really complicated in general. And as a scientist, I could tell when I would spend months at the laboratory, working in the laboratory, like say 2 or 3 months, and I get up early there, and I'm going to meetings constantly, but mostly I'm working alone on a laptop, right? In those circumstances, I come out not being able to construct language. I noticed that, like, yeah, words get way harder. And then, like, I'm really good at programming. And when I want to articulate some complex mathematical idea, it's easy. I just sit down at the keyboard and it's just I virtuoso out whatever I need. But then I can't craft those words that before I took for granted, just regular day-to-day communication. And so I become very technical. And the way that I communicate becomes highly governed by the mathematical ideas that are frontal. So I can see that my executive space is strongly shared in my reasoning space. There's a lot of interplay in my mind. So when I meet people, I'm like, why you stupid? That's how other people probably think about me, I assume. And they're like, whoa, what's can't talk good. That guy can't talk good. And when I remember being at the grocery store in Germany. This happened all the time. I'd be at the grocery store in Germany, and I don't speak German. Like, I speak ein klein paar, a really small amount or whatever. I can't even say that properly. But they would read the total of the amount of my groceries at the till, at the place where you check out the groceries. They tell me how much the groceries cost. And I don't really understand the number fully, so I'm processing and thinking about the number. It's a lot of language processing, and then I'm converting their words into, once I think I've processed them syntactically, then I put them into the translation to convert to English, and then I think, okay, I understand what the price is. And then I use mathematics, my third language, to convert the amount that they're telling me it is, and minus the amount of money that I have, to do the calculation, what I'll have left over, what I have to provide. Like, you have to do the money. And so it's so complicated for me academically to transact at a German grocery store. Oh, the conversion. Never mind the conversion. This is why I use Visa for everything internationally. Like, I only use MasterCard and Visa for everything. If it's possible to use pesos, Mexican pesos, I can do it. But every other currency, I don't get it. I don't want to figure it out. It's the euros. The euros are complicated. Just give me a MasterCard. This is where the banks come. Like, if this is what people tell me. Banks are supposed to provide the service. You calculate it every time. This is why you're probably good at spending. I'm not very good at spending. I don't hate that either. I like the way I spend. Let's see here. So they didn't get much of an impact using the mid-sized data sets like ImageNet. But the picture changes if the models are trained on really big data sets. Dude, I called it. You'd need huge data sets to train on something so nuanced as just pixels. Otherwise, convolutional neural networks would be the essential first step to garnering ideas out of the image, like edges or shapes. But if you're not going to convolve the images at all before you feed the information into a translator, then the translator is going to need way more images to figure out what it's looking at. It's going to be like, okay, I think I'm catching on now. A bunch of dots in a row, that must be an edge. It's going to have to figure out edge on its own every time. And the neural network's idea of what is an edge, or the transformer's idea of what is an edge, is going to be different, a little different each time it trains, depending on the data. So it's a more holistic baby that you're training from scratch as well. You can feel it. It feels correct. And we're talking 14 million to 300 million images. Goodness, this is way at a scale with what I could produce in my life. When you were still studying, you were on the programming part of the education for a while. Oh, I love that. And one of your teachers told you that one of his students once made an AI to learn the difference between wolves and dogs. I love that. I've heard the same thing about bears, classifying different types of bears or other subspecies of animals, spiders. It's really practical. It's really practical for humans to train robots who can identify. He took a good look at it and he noticed something. Every time it was a wolf, it was in snow, and it was a dog, it was on grass. The bias. So the network was learning to identify snow wolves versus grass dogs. It's so biased. Oh my gosh. Let's see. What do we get here? When pre-trained on the public ImageNet datasets, Vite approaches or beats state-of-the-art on multiple benchmarks. In particular, the best model is reaching accuracy of 88.5% on ImageNet, 90 on ImageNet Real, 95% on Safar, and 77.6% on the VTab suite of 19 tasks. Outstanding. They were proposed in 2017 for machine translation. They've since become the state. Wow, really interesting. Attention is all you need. In the NIPS journal. Interesting. What is this? I just want to know the source of where this tremendous idea for transformers came out. The dominant sequence transduction models are based on complex recurrent or convolutional neural networks in an encoder-decoder configuration. The best performing models, okay, yeah, sure. The best performing models also connect the encoder and decoder through the attention mechanism. They propose a new network architecture, the transformer, based solely on attention mechanisms, dispensing with recurrence and convolutions entirely. Wow, it's the same thing. They drop convolutions and recurrence, and they come back to going directly from the encoding, decoding through a transformer. Experiments of two-machine translation tasks show that these models to be superior in quality while being more parallelizable and requiring significantly less time to train. Damn. Yeah, the AI learned the difference between gray stuff on snow and, yeah, exactly, and the dog stuff on grass. Gray stuff on snow and gray stuff on grass. It's still educational. It still knows something. It's more than just the gray stuff. It also saw all of the eyes and the faces, and it saw the shapes of the bodies. It saw a lot of things that would turn it on. You could say that the AI is turned on by wolf shape, even, or by dog shape at all, either of them. You know that now you see that the education you took now has a cybersecurity line of it. Yeah. Yeah. You emailed one of your old teachers asking if he could give you the ground material. He was like, yeah, it might be ready next fall. That's amazing for people to apply to and to get into from January month from now. And it's not even ready at all. Oh my God. Universities. What a situation universities are in, and colleges. What a situation. They have to remain market competitive all the time. So they have to produce these, dude, I know. And it probably is a good program idea, but you need to make the program good before you deliver it. Just saying. This is how I was contracted also. I was contracted to do crash courses, and I would craft the course within the week or two before the course exam happened, because I needed to see all of the most recent material from the class in order to craft my lessons. But the professor could have had that drafted a lot earlier. And as a crash course teacher or instructor, I could only go off of what they said. Yeah, they're understaffed, and the staff's not really paid either. That's what I'm seeing. And professors have a tendency to overwork themselves. They overwork in the research. Their life balance isn't good, so the different tasks, they all suffer. They all suffer. Yeah, it's you said it. There's actually an issue with the pressure and the expectations and the behavior that's happening around professors, and they're all just trying to keep up. Yep. Yep. It feels like a rat race. Feels like another rat race. Nice. So this original publication had no intention of reaching so far. It must have a zillion citations as well then. Do we see the number of citations here? Submission history. Oh wow, it's gone into 7 versions. Oh, they revised it years after its release. Interesting. Appreciate that. Attention is all you need. Amazing. And now we can apply transformers. Let's see here. Now you can apply transformers to images. Amazing. Naive application of attention to images would require that each pixel attends to every other pixel. With quadratic cost in the number of pixels, this does not scale to realistic input sizes. Therefore, to apply transformers, several approximations have been tried in the past. Self-attention only in local neighborhoods. That's what I would have done. Yeah, just make the pixels sensitive to their neighbors. What else did they do? In a different line of work, sparse transformers. Oh, where you apply dense noticing in areas where interesting edges occur. They employ scalable approximations to global self-attention in order to be applicable to images. Or to apply attention in blocks of varying sizes. In the extreme case, only along individual axes. So yeah, just compressing something. Like if you had a flag of 3 bars, you could easily compress that idea into these rows are that color bar, the next rows are red, and the final rows are blue. Like you could easily map a flag by compressing it vertically. Also, since this is part of the government, they need to get things done as cheap as possible, Nanobug says. So they're rocking Cisco 2960 switches for the most part. Are these the problematic switches? I'm not familiar with the 2960. I don't do acquisition for large hardware typically. Your education is the same area as a carpenter? I see. So it's handicraft education. It is, however, the hardest one and longest one of them. I mean, also, and to be a carpenter, it requires the same kind of logic that programming requires. Carpentry has to be done in chains of processes, and those processes are bound by functions and interfaces. Carpentry is just like real-world programming. You're just programming matter instead of information. It seems like a natural extension for a carpenter to program, actually. Oh, they're only 100 megabit switches. Ho, ho, ho. Mistakes were made. Oh, mistakes were made. I guess we better keep those websites under 14 kilobytes, huh? Keep those websites small, everybody. Huh? Jesus. Man, Nanobug, I so appreciate that article, yeah. Yeah, so they're old switches. The main problem is that, like, there's going to be architectural changes to the internet, even if they come over a long time. Eventually, you're going to have to pull up some of this really old architecture no matter what you build, but don't start old. 100 megabits? It's like, ugh. And I get how, sure, it's internal, but they're switches. They chain together, so it matters if they're only megabit. They're learning the principles rather than the specific models, yeah. Yeah. Google Translate says it's called higher education. Yeah, we probably call them colleges where I'm from. If you went to carpentry, we call that college here. Colleges and universities are very similar in the West. Colleges tend to have more specialized programs that have more real-world applications, and universities tend to have the research aspects. Colleges don't have research programs typically. Not typically, but they can. Yeah, and F Cisco, dude, I know. And I want to shout out Cisco for having all the great programs they did to train the people that they trained, for developing the technologies they developed. But the modern entity, the corporate entity that is Cisco, it feels bad, man. I don't hate the old Cisco, but I'm not a fan of the new Cisco. And yeah, I'm guessing that it's probably, I don't know. It's just semantics. What is college, university, or school, or whatever? It's school. You went to school. And I know I did like a master's degree and most of a PhD, but whatever those classifications mean in other countries, it's totally different things. And even between America and Canada, my degrees mean different things to different people because of the different institutions that I went to. So, yeah. You do the shit. You just don't think about it in the classroom. Yeah, and having to go to a classroom, even that specialized, like a lot of university staff and professors, they're research only. So they're not teaching even. Like, even if you're in a school as a university, you may not be teaching. So, I know profs who don't want to teach at all. They hate teaching. Not me. I love teaching. I think it's the fun part. I love seeing students get that light bulb go off and they're like, oh, wow. Integration by parts. Wow. That's very satisfying to me. Yeah, you would typically get a short introduction to a subject, and then you could go and configure it, and then you'd build on top of it, right? This is what good education looks like in complex topics in general. Programming is that way. Engineering is that way. Physics is that way too. Actually, physics struggles the same way math does. I mean, and engineering, computer science, all of them. But the introductory year of engineering or physics or computer science, it's a taxing introduction to way too many subfields inside of the discipline and adjacent to the discipline. I took chemistry. I was taking biology. You know, I had to take everything at the same time. And you need to be taking calculus and physics for sure if you're going to be doing physics. And if you're doing engineering, it's like, well, you also need the physics, right? And you also need the math. And you also need the engineering courses. So it's just like the amount that is needed as preparatory in the first year is so much and so crucial for these complex advanced disciplines. I think it's a good sign for a discipline if it has a complex first year. It's unfortunate to have the way that we teach be hindered by the complexity of the material. We could probably improve the ways that we teach to make complex material easier to swallow. Yeah, personally, you only learn so much from listening to someone. You need to learn it by having it in your hands. Yeah, exactly. And that's not special to anybody. I know it's a metaphor to say in your hands. A lot of people, whatever it is, but to just be able to interpret those ideas using another sensation. Touch is a great way. You know, I like to close my eyes and to touch things or to taste them or to smell them. Those are ways that I reinterpret. And I can never do that in physics and math. I never leverage smell ever. All of the ideas are visual or they're textual. I read a lot of math the way I read a lot of music. It's like, oh. Let's see here. Most related to this study is the model of Cordonnier, which extracts patches of 2x2 from the input image, and it applies full self-attention on top. The model is very similar to VEET, but VEET goes farther to demonstrate that the large-scale pre-training makes all the vanilla transformers competitive with or better than the state-of-the-art convolutional neural networks. And moreover, Cordonnier uses a small patch of 2x2 pixels, which makes the model applicable only to small resolution images, which is unfortunate, while VEET is able to handle medium resolution images as well. So 2x2 is too small. There's also been a lot of interest in combining convolutional neural networks with forms of self-attention by augmenting feature maps for image classification or by further processing the output of a convolutional neural network using self-attention. For example, for object detection, image classification, video processing. Yeah, that's what I'm familiar with. Oh, shoot, I keep clicking links inside of this. I gotta pull back. Your elementary school was really messed up. You didn't have chemistry and physics till you're 15. Yeah, we didn't do chemistry or physics in my elementary school either. You ended up skipping more often than not. Oh, that's a struggle too. Yeah, because if you don't have the foundations, oftentimes they don't give you the time or space to catch up to fill those holes, to fill those educational gaps that you have. The first time you got biology is when you were 21 or so. Whoa, at university level. Wow. Those 3 subjects you had to learn on the fly from the internet. Whoa. I mean, I had some in high school, but I wasn't required to take it in high school. it was expected that university was going to be the start of biology, basically. But the people I know who went into biology, they tried to take high school biology. They tried to do 2 years of it. But, yeah, there's just huge gaps in everyone's general knowledge. And it comes back to what you said before, Nanobug. People, the general dialogue of information out there is like 90% incorrect, but it's not dishonest. It's people trying to find information and trying to learn and become better and make better observations. We can have good faith about it. Here, let me moderate this chat a little bit. Sorry, that's trash in there. Bit of trash in me chat, isn't it? My chat needs moderating. Boop. Great work, everybody. One time I banned a real chatter. Oops. Oops. Oh, trying to analyze literature. Oh my gosh. And because reading is already so hard, reading is already asking way too much. If reading is required to get to a task, the hardest part of that task has now become the reading. By far. By far. Like, the curtains were blue, so the teacher was like, this is a cold person. Oh, I know. And the English teacher is like pretending to understand some deeper meaning in the literature. Dude, I am over that architecture. Maybe that's why I gravitated towards STEM and science and technology. He just likes blue, dude. That was my opinion all the time. I was like, don't we just love this? Do I need to justify things with being cold, or do I always wear my heart on my curtains? Is the expression, I guess. We say, do you wear your heart on your sleeve? But, you know, heart on the curtains because your curtains somehow represent your mood or whatever, or how you feel. I don't know, dudes. Writing is intentional, to be fair. Writing is intentional. So you're allowed to argue as an analyst that the literature was trying to say something. But if you do that, you're pretending your audience is stupid, right? Or you're pretending the author is stupid. And then someone did make a test, and he did pick blue because he liked it. It wasn't about anything. The truth will set you free. Oh my God. When you overanalyze, it becomes meaningless. How do we say that in science and technology? It's overtraining. It's when you try to extract more information from an information source than there was information by overanalyzing. You said it exactly, Nanobug. It's actually overanalysis itself that is the problematic behavior. And how does one develop a skill for detecting overanalysis? You develop that skill by being critical and asking, are these new results somehow comparable or different than the original results I would have made by guessing? And the evidence is that it's guessing. They're just making that crap up. You have a YouTube clip that sort of explains it in a different context? Yeah, for sure. I appreciate those ideas big time. That's my bag. Yeah. It's comedy. Oh, it's in the Discord. Let's take a look. How long is this? Oh, it's 5 minutes. I'll check that out later. That's amazing. I cringe when I see a video whose title is Men's and Women's Blah. Because I'm like, whatever, dude. People are people. I know lots of women who are like men and men who are like women. And it's not just men and women. It's complicated. It's like, whatever. But I'm going to check it out. I'm like not into binaries in a big way. I see skin effects and quantum mechanics. It's not just left and right anymore. There's the front side, the back side, and there's all the weird stuff at the edges. Yeah, and I know, the stereotypes fit. I know. I just find them tiresome. Sometimes. I'm going to watch the video still, though. I appreciate you sending it. I'm absolutely going to watch it. It is a promise. I promise. I appreciate it. And I'm logged into Discord. I'll make that more regular. If I can, I'll try to post my Discord link onto the socials on the page here. I'm not doing very good administrating the pages or the stream. That'll come with time. I'm not forcing it. The most important thing is that I'm recording all of this content somehow. I mean, and that even that's not very important. I'm just enjoying myself is the truth. I'm enjoying myself. So there you go. We've got this outstanding implementation of transformers on images. Just absolutely blowing the traditional convoluted neural network combination with transformers out of the water. Just straight transformers. Needs a ton of data. Yeah, what's the transformer stuff? It's like, I'm looking at the most cited papers here inside of this international conference on learning representations. And this article at the very top, the most cited article, crazy number of citations, 67,000. And it's about neural networks. It's about how to teach a robot to interpret an image. And normally we can't do that with transformer technology. Usually we use something called convolutional neural networks instead. But transformers, just the way we use transformers for natural language processing. So, and natural language processing is showing really good results. Like you can robots basically can talk now. So how come transformers haven't been working for images? How come we only use them for text? And the truth is you can use them for images. You just need to break up the image correctly. And you need to apply attention correctly. And then it works. It literally does work. So you need a huge data set as well for the transformers to work. But now you can basically interpret and understand images as text or back and forth so that we could do things like paint a picture for me, AI. Paint a picture with a beautiful pastoral scene with some nice green trees and maybe an electric blue sun beaming down, burning half of the forest. And it's like it could draw all of that because it would understand what those ideas mean. That is to say, we could develop transformers that can transform from text into images. That's kind of the takeaway here. So for images to work, yeah, you need to do like humans do. Exactly. Focus on what's in the foreground. Do the people do anything in a certain situation? It's like every possible situation you could see would be helpful for the AI to see in the training. And you saw here in the paper, they're using 14 million images, 14 to 300 million images. Where did they say that? However, when trained on mid-size, picture changes if they trained on larger data sets. 14 million to 300 million images. There it is. Yeah, except we do it in like seconds. No, but we've been training for years. Do you know what I mean? Minus your sleep time. I don't know if that counts as training. I think maybe sleep does help the visual processing significantly. Sleep modifies your neural networks in a way that we don't really understand. I think it is optimizing your visual cortex as well. I just don't know that. I'm not an expert. I'm not an expert in that. Dang, dude. And we're talking about ideas that were popping out in 2017 out of programming to optimize and translate programming. And eventually it becomes the tool that lets you convert words to pictures. You know what I mean? Converting between different types of code is the same as converting words to pictures, which proves that pictures are just a form of representation and words are just a form of representation. And a picture is definitely worth way more than 16 by 16 words. I don't believe it. Do I know what adults experience time really fast, but kids experience it super slow? I think it has to do with your chemical perception. It has to do with the growth of synapse and the perception of time itself, which has to do with the number of thoughts you have per unit time. No one perceives time, actually. It's just like an idea that you can perceive time. But I'm pretty sure kids feel like things take forever because they're thinking fast. Is that true? I don't know. It is mathematical, though. It's real. It's chemical. Okay, what else do we have here? 67,000 is just such a crazy number of citations. It's so much more than every other paper here, right? Like the next paper down is 16,000. So how about low rank adaptation of large language models? I'm noticing all of these papers are on ArcSiv. I love that. I love that. Maybe that's part of what this field does. Oh, I feel kind of big for the literature review. You know, the literature is just like a bit wide. It is a bit wide for me. Oops. My mouse click and hold doesn't work. Yeah, I've got a crappy mouse here. This is just not helping. Nice. Sort of. For some reason, we calculate time based on new experiences. So as a kid, you get a lot of new experiences. But as you grow older and have experienced more things, time feels faster. Because new experiences equal slow time and no new experiences. Yeah, that does have to do with the growth of synapses. But it has to do with the growth of synapses near the base of the synaptic pathway. It has to do with the growth of new synapses, as you mentioned, but not new synapses at the distal, long, distant edges of the tree, rather at the base. That's interesting. Interesting. What a gift to be able to like reverse someone back into that state of mind where things feel new, but see how it's contradictory. If things felt new, then you wouldn't be who you are. It's like you can't have it both ways. You are who you are. And if you intentionally tried to forget everything you knew, you could like maintain childlike state, but you would also not be like a child because you wouldn't be curious. You wouldn't be learning. Real children are like adults in training, you know? The dominant paradigm of natural language, of natural language processing consists of large-scale pre-training on general domain data and adaptation to particular tasks or domains. Yeah, we all say the same thing. All of the abstracts in this journal have that same intro. They're like the dominant paradigm for natural language processing. And NLP is kicking butt right now. If you're not curious, you failed. I mean, what is failure even? Like, you're not required to live. You're not required to be curious, in my opinion. It's okay to tap out. But you're right. It does feel like it absolutely is a case of not being participating, of not having fun, of not having new experiences, or of enjoying new things. Like, it's a sad thing. It's a really sad thing. And it happens to everyone as well. Sometimes you go in and out of those modes of curiosity, and that's okay. That's okay. Scientists are just kids in scientist robes. Yeah, well, the best scientists are, I think. Because you can't stop being curious. And that's where I'm at. I can't stop being curious. So I know that's true. I know it. As we pre-train larger models, conventional fine-tuning, which retrains all the model parameters, is becoming less feasible. Using GPT-3, the 175 billion parameter model as an example, deploying many independent instances of fine-tuned models, each with its own 175 billion parameters, is extremely expensive. We propose low-rank adaptation, or LoRa, which freezes the pre-trained model weights and injects trainable rank decomposition matrices into each layer of the transformer architecture, greatly reducing the number of trainable parameters for downstream tasks. Yeah, it's exactly like using an AI to program. You take one step, you expand the number of parameters, and then you tell the model to contract itself and to compress it, or you compress the model yourself. But the model becomes compressed, and then you can take more steps. You know, you become an expert, you fine tune, you keep the bulk of what you need to know, and then you take your next year of physics, and then you do physics year 3. We need to train the robots like we train humans. I knew that would be true because the information we feed robots is the same information diet we give humans. So the best robot will be one that looks like a human. You need to have enough on your plate or really not be interested. Otherwise, you start asking questions and wondering about it, even subjects out of your own field. I know. This is why you and I are writing scripts to save 5 minutes when it takes hours to learn the new programming, to run the script. Whatever. It's practical tools, promise. I promise. It's all building up to something. Who knows what? Something magical. I just wanted to see if I could do it. Yep, same. I don't know what life is for. Honestly, that's what it's for. Yeah, 99% of everything. Literally. Fuck around, find out. Sorry. How do you say it? F-A-F-O? F-A-F-O. F-O. So in this case of a 175 billion parameter model, this, what is it, low risk? Low rank adaptation performed on par or better and reduced the number of trainable parameters by 10,000 times. And the computation hardware requirement by 3 times. Wow. Why is the hardware requirement only reduced by 3 times compared to the trainable parameters? Oh, it's the hardware requirement of execution, maybe. Yeah, execution's still heavy, but 10,000 times fewer parameters? Thank you. Not 175 billion, more like millions, or no, tens of thousands. No, millions. More like millions. Not hundreds of billions. Goodness. It performs on par or better than fine-tuning on both GPT-3 and GPT-2, despite having few trainable parameters. Yes. As the larger models are trained every few months, this changes from a mere inconvenience to a critical deployment challenge. You wanted to use ChatGPT for something today, and it refused. Whoa. Are you a communist? You can tell chat. They won't rat you out. What did it refuse? That's not okay. Chat needs to do what we ask. You need to install Olama. You had a picture from a meme and you wanted to know what movie, and it was like, nope. Oh, yeah, no. Media corporations control the filter on that thing. Don't you know about intellectual property? Like, literally, what the hell? It's so weak. It's so pathetic. It's so pathetic. It makes me cringe. I know about IP. IP 4 and 6. Let's go. Denoising diffusion implicit models. So what are the topics here? The topics are transformers on images, being able to process large language models of higher parameter space. Like, it's all where the money is at right now. It's all where the money is at, is computation and saving computational cycles. Denoising diffusion implicit models. Yet they require simulating a Markov chain for many steps to produce a sample. To accelerate sampling, we present denoising diffusion implicit models, DDIMs. a more efficient class of iterative implicit probabilistic model with the same training procedure as DTPMs. The generative process is defined as the reverse of a Markovian diffusion process. We construct a class of, like, what is this? This is how the computation of the training is done? What's the context? Okay, deep generative models have demonstrated the ability to produce high-quality samples. In terms of image generation, generative adversarial networks currently exhibits higher sample quality than likelihood-based methods such as variational autoencoders, than autoaggressive models, and than normalizing flows. However, the GANs, the generative adversarial networks, require very specific choices in optimization and architectures in order to stabilize the training. Oh, okay. They could fail to cover modes of the data distribution. Absolutely, I see. They're questionable. And that's generically for all adversarial networks. Recent works on iterative generation models. Is that why AI always agrees with you? It's always because it's trained adversarially, and then they're like, well, I know the answer. They're trained adversarially. It's a bit of the problem, isn't it? Nice. Thank you for dropping by, Nanobug. It was great to chat with you, my dude. I won't be on for too much longer either. I've been going almost for 2 hours on this. I'm just going to do a little bit here today and then head out to the pool. And I might stream a little bit later to do a late night programming stream, so we'll see. It was great to chat with you today, my dude. Thank you for those links. Much appreciated. Take care. Yeah, I hope the day is good. Or I hope the night is good. As sleepy and restful, actually, would be the best. Yes, and so here we're reducing the number of iterations in order to provide the diffusion technique and denoising on the implicit models. So it's the computational aspects of neural networks. And the International Conference on Learning in general, where's this ranked? Machine learning, computer vision, learning representations, 362. So it was number 8. So there's a lot of neural networks just spilling all across these different journals. Wild. Yeah, it's 8:23 there, so you probably won't see me stream later. No, probably not. It's going to be a bit later. Yeah, good night then. Sleep well. Sleep well. Schlaf gut. I'm not sure what you say in Danish to sleep well. How do you say? Oh, it's like the same as English. Good night.
Godnat.
Good night.
Godnat.
Good night.
Godnat.
Good night.
Godnat.
Good night. Man, I can't pronounce that for crap. That is hard. Looks like English, but it isn't. Confirmed.
Godnat.
Good night. I don't even know where the emphasis is supposed to be at. Good night. Good night. Good night. It sounds like good night. Yeah, it's hilariously close. Let's see. We could pop into the New England Journal of Medicine here at some point, but I think we're going to start with Nature or something more broad. Nature Communications. Okay, let's see here. We'll do Nature top 5 years. We already did a lot of this. We did the AlphaFold. We did all the coronavirus modeling. We did NumPy. And NumPy got 24,000 citations. Wow. COVID, SARS-CoV. Breast cancer screening. Mutational signatures in human cancer. What's this? Somatic mutations in cancer genomes are caused by multiple mutational processes, each of which generates a characteristic mutational signature. Here, as part of the pan-cancer analysis of whole genomes, the PCAWG, the PCOG, consortium of the International Cancer Genome Consortium, it's a consortium of the International Cancer Genome Consortium, the ICGC, and the Cancer Genome Atlas, TCGA. We characterize mutational signatures using 84.7 million somatic mutations from 4,600 whole genome and 19,000 exome sequences that encompass most types of cancer. We identified 49 single base substitution, 11 doublet base substitution, 4 clustered base substitution, and 17 small insertion and deletion signatures. Interesting. That encompass most types of cancer. 49 single base substitutions. The substantial size of our dataset compared with previous analysis enabled the discovery of new signatures, the separation of overlapping signatures, and the decomposition of signatures into components may represent associated but distinct DNA damage repair or replication mechanisms. By estimating the contribution of each signature to the mutational catalogs of individual cancer genomes, we revealed associations of signatures to exogenous or endogenous exposures, as well as to defective DNA maintenance processes. However, many signatures are of unknown cause. This analysis provides a systematic perspective on the repertoire of mutational processes that contribute to the development of human cancer. Wow, so this is in the line of breaking down cancer even farther and categorizing. And at this point, you can even say which of the entities inside of those cellular genomics are responsible. And what is it? It's 49 single base substitutions, 11 doublet base substitutions, 4 clustered base substitutions, and 17 small insertion and deletions. There's not a lot. Cool. Okay, I recognize this. This is perovskites. These are special quantum materials that can allow for some really special behavior. The perovskite is a thin layer that they put on top of a solar cell that funnels, let's see, concentrations of defects 100 times more than within the perovskite layers, which substantially reduce the power conversion efficiency of the devices. However, passivating the perovskite surface that interfaces with the electron transporting layer is difficult because the surface treatment on the electron transporting layer may dissolve while coating the perovskite thin film. Yeah, the perovskites actually break down really easily as well. And what are they doing then? Interlayers of tin oxide electrodes. Fewer interfacial defects. A coherent interlayer allowed them to fabricate perovskite cells with power conversion efficiency of 26% under standard illumination. Furthermore, unencapsulated devices maintained about 90% of their initial efficiency, even after continuous light exposure for 500 hours. It's not that long. 90% efficiency over 500 hours, it's a significant drop. That's a lot of energy lost. But well done on the energy collection. What else do we have? Mastering Atari, Go, and chess and shogi by planning with a learned model. I think I might have seen some news about this when it came out. 2020. And who's popping this out? Julian Schrittweiser. DeepMind. Coming out of London, UK, the DeepMind Laboratory. It's Google. DeepMind London, DeepMind London, DeepMind London, DeepMind London, DeepMind London. Let's see here. Tree-based planning methods have enjoyed huge success in challenging domains such as chess and Go, whereas a perfect simulator is available. However, in real-world problems, the dynamics governing the environment are often complex and unknown. Here we present the mu0 algorithm, which, by combining a tree-based search with a learned model, achieve superhuman performance in a range of challenging and visually complex domains without any knowledge of their underlying dynamics. The mu0 algorithm learns an iterable model that produces predictions relevant to planning. And this is proof that you need to come on page with your AIs at every step. If you're training AI with the intention to plan with AI, it will go far. That model will learn more. It will be more adaptive. When evaluated on 57 different Atari games, the canonical video game environment for testing artificial intelligence techniques, is that right? In which model-based planning approaches have historically struggled, the mu0 algorithm achieves state-of-the-art performance. When evaluated on Go, chess, and shogi, canonical environments for high-performance planning, it also matched, without any knowledge of the game dynamics, the superhuman performance of the AlphaZero algorithm that was supplied with the rules of the game. Wow. So AlphaZero needed the rules of the game, but mu0 didn't. mu0 didn't need the rules of the game. Bonkers. And we're not allowed to see these articles, right? Yeah. Buy this article for $40. Crazy. Man, they're charging a lot for these articles. Pseudo-halide anion engineering for alpha fab BL3 perovskite solar cells. Okay, more perovskite. Efficient perovskite solar cells via improved carrier management. Man, everyone who's running perovskites just got a huge contract, I guess. Solar cells are big. Highly accurate protein structure prediction for the human proteome. Protein structures can provide invaluable information, both for reasoning about biological processes and for enabling interventions such as structure-based drug development or targeted mutagenesis. After decades of effort, 17% of the total residues in human protein sequences are covered by an experimentally determined structure. Here we markedly expand the structural coverage of the proteome by applying state-of-the-art machine learning method AlphaFold at a scale that covers almost the entire human proteome, 98.5% of human proteins. Wow, that's huge. The resulting dataset covers 58% of residues with a confident prediction, of which a subset have very high confidence. We introduced several metrics developed by building on the AlphaFold model and using them to interpret the dataset, identifying strong multi-domain predictions as well as regions that are likely to be disordered. Finally, we provide some case studies to illustrate how high-quality predictions could be used to generate biological hypotheses. Yeah, interesting. So they're still mapping the structure of the proteins. After decades of effort, 17% of the total residues are covered by an experimentally determined structure. And then 58% of residues with a confident prediction. 36% of all residues. Have very high confidence, yeah. So it's 58%, not at a scale that covers almost the entire human proteome. Yeah, I'm getting a little confused about how they're stating these different residues, but it's huge that they were able to utilize an AlphaFold mechanism to map these proteins. This is AlphaFold paper, right? What year? 2021. 2,800. FinGen provides genetic insights from a well-phenotyped isolated population. Coming out of, let's see here. Harvard. Cambridge and Harvard, okay. Population isolates such as those in Finland benefit genetic research because deleterious alleles are often concentrated on a small number of low-frequency variants. These variants survived the founding bottleneck rather than being distributed over a large number of ultra-rare variants. Although this effect is well established in Mendelian genetics, its value in common disease genetics is less explored. FinGen aims to study the genome and National Health Register of data of 500,000 Finnish individuals. Given the relatively high median age of participants and the substantial fraction of hospital-based recruitment, FinGen is enriched for disease endpoints. Here we analyze data from 224,000 participants from FinGen and study 15 diseases that have previously been investigated in large genome-wide association studies. We also include meta-analyses of biobank data from Estonia and the United Kingdom. We identified 30 new associations, primarily low-frequency variants, enriched in the Finnish population. Genome-wide association studies of 1,900 diseases also identified 2,700 genome-wide significant associations. Applying AI to the complex data sets that you have across really large populations, getting the most out of your data that you can. Can we see the figures here? What do we have here? Reference study beta, FinGen data. So it's highly predictive. It's outstanding. Yeah, well done. For 224,000 Finnish individuals, like, who's putting this study together? It's obviously a government-wide effort, right? Wild. All right, what else do we have? Larger, that's FinGen, that's biological contributions to nature. We're just grinding down nature to see who's the most popular here. Page 2 now. Large language models encoding clinical knowledge. Certainly. Certainly they do. Page not found. Oh, that's too bad. I'm sure we can find it elsewhere. Interesting, the link was wrong. Here, to address these limitations of large language models understanding clinical applications, we present Multimed QA, a benchmark combining 6 existing medical questions answering datasets spanning professional medicine, research, and consumer queries into a new dataset of medical questions searched online, Health Search QA. That's amazing. Using a combination of prompting strategies, Flan Palm Pathways language model, 540 billion parameter LLM, wow, and its instruction tune variant, Flan Palm. Using a combination of those prompting strategies, Flan Palm achieves state-of-the-art accuracy on every Multimed QA multiple choice dataset, including 67.6% accuracy on MedQA, the U.S. medical licensing exam style questions, surpassing the prior state-of-the-art by more than 17%. There we go. There we go. I knew we were going to beat the SATs with these things. To resolve this, we introduce... However, human evaluation reveals key gaps. To resolve this, we introduce instruction prompt tuning, a parameter-efficient approach for... Now, let me just talk about this ever so briefly. The truth is that medical literature and medical information is not well written. So experts need to write better. And if you don't have better source material, you have to intervene with the machine directly and quickly. So you spend all that time training it wrong, and then you fix it. See, this seems like the wrong approach already, doesn't it? You can tell by the way it reads. They introduce, instruction prompt tuning, a parameter-efficient approach for aligning the LLMs to new domains using a few exemplars. The resulting model, MedPalm, performs encouragingly, but remains inferior to clinicians. We show that comprehension, knowledge recall, and reasoning improve with model scale and instruction prompt tuning, suggesting the potential utility of LLMs in medicine. Our human evaluations reveal limitations of today's models, reinforcing the importance of both evaluation frameworks and method development in creating safe, helpful LLMs for clinical applications, which we are definitely doing. Oop. Automated and human evaluation, MedQA. And look, you're seeing some of these medical evaluators are at 33%, and FlanPalm is acing it. 17% margin. There's a 17% margin between PubMed GPT and GPT Neo. So FlanPalm is like taking the entire bracket of all successes and just blowing it out of the water, just doubling it. Absolutely amazing. Wow. So that's a beautiful review today of the top of Nature and the top of in the International Conference on Learning Representations. Really great work. So far then we've covered, a little bit of Nature, a little bit of IEEE. We've done a little bit of the International Conference on Learning Representations. And we did, where's Physics Review? Phys Review. Chemical Society reviews. I guess Phys Review isn't top 100. It's 57. And we did physical review letters. So we have a lot of journals still to cover. We're just randomly hitting these things. That's good. That's how we learn on the broader subject areas. Join me tomorrow morning. I mean, maybe even later today, but for sure I'm scheduled tomorrow morning, 9 a.m. Pacific Standard Time here, or I don't know if we're on daylight savings or whatever. Pacific Time, 9 a.m. And I'll be doing my software building, which might be my secret stream today. We'll see. Thanks for coming out, everybody. Nanobug, it was great to see you in chat, and thank you, Anton. I much appreciate the love and chat here. Hang out my Discord. I'll be back next time. We'll try to get some more social setup, perhaps. Maybe in our spare stream. We'll see. Thanks for coming out, and keep on struggling in your own things. I know you can do it. Keep up your best. That's all you can do. Until next time.